Again, welcome to Mathematics 164. This lectures cover chapter 3 of our course textbook. That's a multiplication of matrices. Our main objective is to learn how to multiply two matrices. So here, many computations that occur in business and also manufacturing operations can be expressed and analyzed by using matrix multiplication. So for example, suppose one store of an electronics retailer has 30 plasma TVs and also 20 LCD TVs and 10 home theater systems in its inventory. Now, if the value of each plasma TV is $800 and that of LCD also is $750 and the home theater system is $500 each, then the value of this inventory will be, we have 30 plasma TV, each is $800. So it will be 30 times 800 plus 20 times 750 plus 10 times 500. Again, we have 10 home theater and each is $500. So 10 times 500. The total will give us 44,000. Now we can calculate this mathematics by using a matrix. So let's assume in matrix A is the quantity of the items we have, and matrix B is the price for each item. Or matrix A is the price of each items, and matrix B is the quantity. So here we have matrix A as 800, 750, and 500. Then matrix B is 30, 20, and 10. Now, in order to do a multiplication of matrix, the number of columns in the first matrix must equal to the number of rows in the second matrix. And here we have 3 columns for matrix A and 3 rows for matrix B. So we can do the multiplication. So we are going to multiply 800 times 30, then 750 times 20, then 500 times 10. Then we add all of them together. So here we get 800 times 30 plus 750 times 20 plus 500 times 10. And the total will give us again 44,000. Now here we say this is a useful way of operating with row matrix and column matrix, which is called the product of A and B. Now one thing we should take a note is that in mathematics, 3 times 2 is the same answer as 2 times 3. But in matrix, A times B will be different from B times A, since we are using rows and columns. So this is the rule here, the product of A and B. We have matrix A from A1 to AN. Matrix B elements is from B1 to BN. So we multiply A1 by B1 plus A2 by B2 plus A3 by B3 plus AN by BN. Then we sum all together. Now, one rule, again, we should know is that the first matrix, the number of columns should be the same as the second matrix, the number of rows. Otherwise, we cannot do the multiplication. So we have a second example from the first. The first example, we have only one retail store. Now, assuming we have a second retail store, and that retail store have 40 plasma TVs, 25 LCD TVs, and also 5 home theater systems. So now we have matrix C with the quantity of items in store 1 and store 2. Remember, store 1, we have 30, 20, 10 from our first example. Now, store 2, we have 40, 25, and 50. Now, if we want to find the total, we can do the same thing by multiply 800 by 30 and by 40, then 750 by 20 and 25, then 500 by 10 and 5, because that's the price for each item, the plasma TV, LCD, and home theater. Now, the value of the inventory for the second store, we are going to get again, $800 is the price, the quantity is 40, plus 750, the price, and the quantity is 25, plus 500, the price, the quantity is 5. So the total will give us 53,250. Then we can add the two together. Now we can perform this by using a matrix. So now we multiply matrix A by C, because matrix C, we have two stores now. The first store quantity is 30, 20, and 10. The second store quantity was 40, 25, and 5. So we are going to multiply matrix A, that's the first row, with the first column. Then first row with the second column. Now, in our previous example, when we multiply the first row with the first column, that's store 1, we get 44,000. So the same thing, we multiply 800 times 40 plus 750 times 25 plus 500 times 5. And that will give us 53,250. And that was the answer here. Now, in order to perform this matrix of A times C, the first matrix A, the number of columns must be the same as the second matrix C, the number of rows. So since they are 3, 3, then we can do the multiplication. Now here we say the matrix we have represented as AC is called the product of the row matrix A, and then the size is again 3 by 2 matrix C. Because again, matrix A, the size will be 1 row, 3 columns. Matrix B and C, we have 3 rows and 2 columns. So 3 by 2 and also 1 by 3. So we can see that we have 3 columns first, then 3 rows, the second matrix, we can do the multiplication. So we should know that the matrix A again have 1 by 3 because 1 row, 3 columns. So matrix C is 3 by 2, and the product of the two will give us matrix A is 1 row, matrix C is 2 columns. So the product answer will be 1 by 2 matrix. The 2 is the matrix C, the second matrix column size, and the first matrix row size will be the final answer. So that's the product of 2 matrices. If I have 2 matrices, A11 up to AMN and B11 up to BMP. First of all, we'll check if these 2 matrices, the first matrix number of column is the same as the second matrix number of rows. So here, let's assume we have 1, 2, 3, and the second also is 1, 2, 3. Okay, so that's correct. 3 columns first matrix, 3 rows second matrix. So we can do the multiplication. So we multiply A11 by B11, then A11, B21, A11 by B11, then we multiply A12 by B21, A1N by BN1. So we take the first row, multiply the first column. Then we can also take the first row multiplied by the second column, first row multiplied by third column, first row multiplied by fourth column. So the answer for first row multiplied by the first column, the answer will be in the first row, first column position, which will be the resulting C11. Then first row, second column, the answer will be what? First row, second column, C12. The answer for first row, third column, the answer will be in the first row, third column. So that's how we have to do all the way to the end. So for example, if I take the second row, I'll use the second row multiplied by first column. The answer will be second row, which is C21, second row, first column. Let's say the last row, we have AM1 up to AMN. I will use that to multiply the first row. That means the answer will be in the fourth row, first column, which will be CM1, the rest. So let's see an example here. Here we have a Pentacle Industries, and they must choose a supplier for raw materials that it uses in its 2 manufacturing divisions at Clarion and Brooks. Now, each division uses different units, amounts of steel, wood, and plastic, as shown in the table below. So we have the steel, wood, plastic, and Clarion, and also Brooks. Now, the 2 supply companies being considered, which is Weston and Costa, can each supply all of these materials, but at different prices per unit, as described in the table. So the steel, wood, and plastic, the Westing Company, they have their price 300, 100, 145. Costa have their price 290, 90, and 180. Now we want to use the matrix multiplication to decide which supplier should be chosen to supply A, the Crayon division, and B, the Brooks division. Now, the lesser the price of the supplier, then we're going to choose. So these are the different amount of products needed can be placed in matrix A, and the prices charged by the supplier can be matrix B. So from our previous table, we saw that the steel, 20 and 22 wood, 30, 25 plastic, and then the Westing price is the first column, Costa is the second column. So here we do our matrix multiplication. First, we check the number of columns in matrix A if it's the same as the number of rows in matrix B. So here we have 3 columns in matrix A and also 3 columns in 3 rows in matrix B. So which means the number of columns in matrix A is the same as the number of rows in matrix B. So we can do the multiplication. So now we are going to take 20 multiplied by 300 plus 30 multiplied by 100 plus 8 multiplied by 145. The answer will be in the position of first row, first column. Then we take 20 multiplied by 290 plus 30 multiplied by 90 plus 8 multiplied by 180. The answer will be in the first row, second column. Then we take 22 multiplied by 300 plus 25 multiplied by 100 plus 15 multiplied by 145. The answer will be in the second row, again, first column. Then the last value, 22 multiplied by 290 plus 25 multiplied by 90 plus 15 multiplied by 180. And the answer will be in the second row, second column. And this is what we have. So we have our first values, first row, first column, first row, second column, second row, first column, and second row, second column. We had everything, and this is our answer. So here we can see that the Westing, 10,160, 11,275 Costa. We have 9,940 for Crayon, 11,330 for Brooks. So based on this, we say the price for the Crayon division for surprise from Westing is in the first row and the first column, and it's 10,160. The price for Crayon for the surprise from Costa is in the first row, second column, which is 99.40. So we can see again, 99.40 is less. So the best price will be the Costa price. Then B, the price for the Brooks division for the surprise from Westing is in the second row, first column, and that was 11,275. The price for Brooks for the surprise from Costa is in the second row, second column, is 11,330. So the best, just a slight difference, we would take 11,275. So we say the best price for Brooks is from the Westing, because Costa is 330, difference of 25. So next, we can do what we call the square matrix. Now, if we have a matrix n by n, which means the number of columns is the same as the number of rows, we call it a square matrix. Now, if a square matrix have one across diagonal and the rest of the elements are zeros, we call it identity matrix. So here we say an n by n square matrix where n is any natural number that has ones down its diagonal and have zeros everywhere else is called the identity matrix. So this is identity matrix, and the size of this identity matrix is 3 by 3. We have 3 rows and 3 columns. Identity matrix is always a square matrix. Then diagonally, we have 1 throughout and the rest is zeros. Now, here we say a matrix I is called an identity matrix because for any 3 by 3 matrix A times the identity matrix is the same as identity matrix times A, and the answer will give you A. Remember, we say in matrix multiplication, if I have 2 matrices A and B, the answer of A times B is not the same as B times A. But if it's identity matrix, A times identity matrix is the same as identity matrix times A. The answer also give you the same A. So let's see this example. They say we should write the 2x2 identity matrix. So this means we're going to have 1, 1, 0, 0, one diagonal, and the rest is 0, 0. Again, the size is 2 rows, 2 columns, 2x2. Next B, they say given a matrix A, which is 4, 13, -7, and 2, we should show that A times identity matrix is equal to identity matrix times A, and the answer should be A. So what we do is that we write the matrix A, which is 4, -7, 13, and 2. Then we multiply by the identity matrix. And we look at the answer here, 4 times 1 plus -7 times 0. That will be the first element. Then 4 times 0 plus -7 times 1, the second element. 13 times 1. And also 2 times 0. 13 times 0 and 2 times 1. And that's the answer. So our answer will be 4, 13 minus 7 and 2. So we can see that A times I is the same as A. And now I times A also will give us the same answer. So we say therefore A times I, or the identity matrix, is the same as identity matrix times A, and is the same as A. So that will be the conclusion of these lectures. Again, these lectures we learn how to find the multiplication of matrices, 2 matrices. The matrix can be any size. As far as the first matrix, number of columns is the same as the second matrix, the number of rows. Then we can do the multiplication of the matrix. Again, thank you. See you in the next lectures.